have noticed that there are some nuances, some struggles. And so I'm excited for this talk because Sharvil is going to talk about how basically you can play nice with the endpoint security framework. So let's give a round of applause for Sharvil.
Morning all, how's it going? I'm going to take a quick photo for Twitter because it's my first time presenting to a live audience. Say hello. Yeah. This is my talk on developing and deploying Apple's Endpoint Security's API in Osquery. As is traditional, this is my Who Am I slide. I'm a software engineer. I mostly do systems programming and work on endpoint agents. Been a contributor and a committer to Osquery since 2015, mostly focused on macOS things. I got elected to be an Osquery technical steering committee member this year, which was super cool. And most importantly, that's my Twitter handle there. So some caveats about this talk. I want to talk about what this talk is not about. This is a developer point of view on what it takes to write code, endpoint security APIs in a widely used and distributed product. Surprisingly and counterintuitively perhaps, writing the code was the less challenging part. Shipping it was a far more challenging task. And I would also say perhaps the more interesting case as well, because this ties in all of Apple's security mechanisms, entitlements, code signing, notarization, gatekeeper, together. And while the endpoint security API headers themselves are very well documented, the whole process to tie this together at this time was kind of opaque and unclear. So I hope you all get some use out of this. So for the sake of time, I won't be covering about any of these, but I'm always happy to chat about it in the hallway later. So I'm not going to talk about ESF internals or how it compares to OpenBSM, or how to use the APIs or how to deploy Osquery or how to use ESF for defense in depth or detections. So this talk, let's define some goals. What are we going to talk about? As I mentioned in the previous slide, writing the code was the easier part. Now we need to tie everything together. And I'm going to use Osquery as the example on how to do it because, well, that's what I implemented things in. So we have two goals. The first one is write code, call the APIs to report and notify on, let's say, process events, and then make the code work, not just on my computer, but on anyone else's computer. So let's dive in. Oh, and kind of lastly, this is to also answer the when ETA question. Thankfully, we don't get those questions, but I want to point that out. Initially did a blueprint POC in like May 2020, load tested it, fuzzed it a little bit, compared it OpenBSM, but the PR was merged in 2021, almost a year later, and shipped in August of 2021. So why did it take so long? Before I answer that, super quick introduction to Osquery. Show of hands, anyone uses Osquery? Cool, that's like 60%, 70%, so happy to see. For those who not in the know, it's a cross-platform endpoint visibility agent, command line tool. It can be run interactively or as a daemon. It basically exposes OS as a SQL. Powerful concept uses the virtual table implementation, so there isn't an actual database. So when you query it, it calls the underlying OS APIs and then generates the data for you. In this example, we are using the launchd table. We are querying the name and program along with its program arguments, where both run at load and keep alive keys are true, and we get some results here. There are a lot of interesting tables. I think it's about 200 now. These are like some of the kind of usual suspects: disk encryption, disk events, extended attributes, app schemes, Chrome extensions, processes, launchd, sipconfig, Yara, USB devices. But since Osquery SQL generates data on the fly by calling OS APIs at query time, we are likely to miss things that happen in between the queries. So Osquery also has what we call evented tables. These have a callback from the OS APIs or a run loop, and we can get the data stored locally in RocksDB even when we are not querying it at the same time. So in this example, I'm querying the hardware events table. I removed and reinserted my YubiKey, and Osquery tells me that. It shows me that the type is IO USB host device, so we know it's an IOKit type class. We know it's USB, so we can further query the USB devices table. And it tells us that the vendor is Yubico, that's the vendor ID, the version, that's what it is, whether it's removable or not. So yeah, and evented tables are very powerful, especially for things like process auditing and the like. We learned the importance of process auditing and things in Patrick and Jaren's classes and training, so kind of another tool in the tool bag. But how does Osquery work? What's the stack? Well, large C++ code base written in 2014 by Facebook at the time. Thankfully uses more than C++ 11 and now C++ 14, so a little bit better than just plain old C++. Sprinkled in with Objective-C++. We use CMake as the build system. We render in all the third-party library, and we almost statically build it. I say almost because it requires glibc on Linux and libsystem and system frameworks on macOS. Also, as a core principle, Osquery does not shell out to get its data. It also does not link against private frameworks and does not use private APIs. There's one call where a private API used, but apart from that, no private APIs. So a large part of doing all this implementation has been kind of reversing Apple's tools, figuring out how it works, and kind of implementing it. So let's get back to our goal. Let's write some code. The code is kind of not super important, but it is the first part to kind of get things in motion. So here we have a subscriber and a publisher. We call that subscribe to, notify exec, fork, and exit events. We get events back, tested it, fuzzed it a little bit, load tested it, compared it against OpenBSM. Looks great, works great. Can we ship it? Well, it works on my machine. Well, not quite. There's a first problem here, backwards compatibility. Endpoint security got introduced in 10.15 Catalina, and with each year, Apple introduces new functionality to those APIs, new symbols. And up until a little bit ago, Osquery was compatible with 10.12 High Sierra, but now we have moved it up to 10.14. So we can see in the V tool there, like the load command that sets the minimum macOS as 10.12 and the SDK as 10.13. We can also like cross-check that from Osquery itself. And here's the O tool output. We don't link against any private frameworks. I have highlighted the weak linking there for endpoint security. Come back to that. That's required to kind of make it work. The other thing is, thankfully, Apple provides these Clang attributes, built-in available attributes. So we can like say, is this available on 10.15 and higher? Run this, else just peace out. So we solved backwards compatibility, right? Works on older machines, doesn't crash. And by backwards compatibility, I mean it won't generate data, but it won't crash because symbols are missing. Can we ship it yet? No, not quite. We tackled goal 1. We have written the code. And that brings us to goal 2, making it work on other people's computers. And that brings us to entitlements. This is Apple's way of doing declarative capabilities, which, when granted, allows us to use certain APIs and functionality. And if you're granted one, Apple has deemed you worthy. For Apple folks now, please cover your ears. I've heard horror stories about this. I've heard rumors that you have to, I don't know, sacrifice your firstborn child or a pet. Thankfully, those rumors are false. But it is an opaque process. I've been lucky enough to granted one on my personal developer ID, on the Osquery Foundation one, on my work developer ID. But if you need this, please start early. It took us like 6 months. And on the form, Apple has a form like, why do you need this? What are you going to do with this? I basically wrote an essay like, hey, here's the work I've done. Here's my Twitter. Here's my GitHub. Here's the commits. Please give me one. So if you need it, please start early. Entitlements are basically key value pairs. It's basically a P list here. We need the endpoint security client entitlement from Apple and set it to true here. So when you pass this to CodeSign along with your developer identity, this gets baked into the code signature of the executable, and that allows Apple to kind of assess whether you're granted this functionality or not. If you're using Xcode, it's a lot easier, but if you already have a tool which is cross-platform and you don't use Xcode and you need to kind of bake this in, yeah. So we got entitlements, right? We can code sign with my identity, force it, pass in the entitlements, and works on my machine, right? Can we ship it? Well, no, it doesn't quite work on other people's computers yet. That brings us to provisioning profiles, but let's narrow our goal a little bit. Instead of trying to figure this out for everyone's computer, what would it take for me to run this entitled and code-signed binary with endpoint security on my machine and a handful of other machines that I control? This brings us to provisioning profiles. They're pretty common on iOS, but I don't think they're widely used on macOS. I may be wrong. All the resources I could find online were for iOS, but the concept is the same. Provisioning profile, basically, as the name suggests, provisions a device. It allows a certain app or executable with certain privileges or capabilities, the entitlement, which is tied to a developer ID, and basically, it's an allow list. So in this example, I've created a provisioning profile with my development developer certificate. I've added a couple of devices, so you got to go to the dashboard, get your UUIDs of the Mac, add them, and then it'll generate a profile. You can download it, and then if you double-click it, you can find it in System Preferences. With this, I can now run the entitled code-signed binary, and it works locally without VMs or without SIP being disabled. So that's great. This is progress. This works on all the computers where I've added the UUIDs off into this profile, and that's great. But I have grander ambitions. I want to ship this to everyone. But I can't potentially add every current and future UUIDs to my account, right? So that brings us to embedded provisioning profiles. When we use the distribution certificate, we generate an embedded provisioning profile, and we can see that this sets the provision all devices to yes. And this is what we'll use to get our job done. So we're done, right? We just ship this embedded provisioning profile along with the binary. Done. Well, not so fast. Kinda. We're getting there, but not quite. As the name suggests, embedded provisioning profile, we have to embed it into something. That something is the app bundle. But Osquery D is a command line tool, has no UI, has never shipped a UI. What do? Well, we have to create an app bundle. We can't use Xcode because, well, we have our fancy CMake and all the scripts tied together. We don't want to touch that. And we use CPAC to create new packages, whether they are PKG, MSI, DEB, or PM, or just tar, GC. So what is an app bundle? Well, as Jaren and Sal discussed in their talk. It's just a directory structure with info plist and this package info thing. Thankfully, this package info is just Apple and some bytes, and I just grabbed it off Xcode's sample template, and it works. So at this point, I needed to do a quick proof of concept. I can worry about how to do this in CMake and CPAC later, but I wanted to make sure that this approach of tying all this together actually worked. So I just followed what Xcode does, created a script by hand, and handcrafted my package or app bundle with hard-coded info.plist and a package info and embedded provisioning profile and all the required bits, code signed the binary, code signed the application bundle, and it worked. I shipped it out to a couple of other machines where I didn't have the UID. It worked. So this was now time to port to CMake, which is tedious but doable. I won't bore you to that. There's an Osquery packaging repo on GitHub. If you're curious, you can check that out. But now we have made progress. We can create an app bundle. We can code sign it similarly to the binary. So let's recap of what we have done and what we still need to do. We have written the code. That's great. We fixed the backwards compatibility linking issues. That's great. We got the entitlements from Apple. Yay. We got our provisioning profiles in order. We code signed the binary. We packaged Osquery as an app bundle. We code signed the app bundle. What's left? Notarization. You all probably know more about notarization than I do, so I'll be quick here. But thankfully, Apple's documentation about this is pretty decent, so that was super helpful. And we can automate most of this. So we are using GitHub Actions. Briefly, we tag a release. We build, test, verify Osquery. We download the artifacts. We launch a new macOS runner, create a temporary keychain, import our secrets, code sign the binary, code sign the app bundle, create a PKG, product sign the PKG, and then notarize the PKG. So can we ship it now? Yeah, we can. We have a valid signed PKG install. Here I'm using apprency. We can see, it's a fat universal binary. It's hardened. It's notarized. It has entitlements, gatekeeper checks, code signature checks, and that's what the app bundle looks like after it's code signed. So everything's good. Gatekeeper is happy. We can use the endpoint security functionality, which is all good. And yeah, we can ship it now. That works. So why did we do all this hard work, right? This was a long, arduous process. I want to write code. I don't want to fiddle with shipping and packaging up things and all that. Well, Osquery already had process auditing via OpenBSM, but OpenBSM has been neglected for decades now. And endpoint security is kind of awesome. And every new macOS release has cool new event types. So I think all this hard work kind of paid off and will kind of pave the future for newer kinds of detections, newer data. And that brings us to venturing into the future. These are the new event types that Ventura brings us. This will be kind of cool to add in. Yeah, so to recap, we wrote code. We made it backwards compatible. We got the entitlements. We did the provisioning profile dance. We created an app bundle for our CLI tool. We created a package. We code signed everything, notarized the package, and it works. And I hope to add these in the future, or if someone wants to take a crack, it's all open source, please do. And that's my talk. Thank you all. Just want to give some acknowledgements. It takes a village to kind of build a massive open source community, so they're awesome. Trail of Bits, where most of this work started, is also pretty good, and all for being such a supportive crew. Some of the resources here if you want to check it out, and I'll be around for questions.
That's a question. Question. So you mentioned Ventura is adding some of these new events that the endpoint security framework. Did you look more into the XProtect one for remediation? I would just be interested in how do you like trigger that, test that, what information it gives you, because that seems like that would be super useful.
I sadly haven't gotten Ventura running in a VM on an M1, so that's kind of my, I don't know, I need to get unblocked on it, but it'll be super cool to figure that out. I really want to like play around with it. So as soon as I get some days off, that's my task. Yeah.
And follow up to that, do you think Apple's adding those like internally, or people like yourself are asking, hey, it'd be great to add that? What's kind of the whole process with that? Because it seems like it's moving in a good direction, so how do we continue that?
So I don't know, like I've talked to Apple, but I never get any responses back unless I'm presenting.
They're here at the conference, so.
I got an email back, hey, please share your slides. I'm like,
they always ask for that.
Yeah. But I think Apple is also going to use this internally, or
Sure.
that would be pretty good if they do, and I think that kind of makes it even better. And if they can detect it, and we can detect
Win-win.
it, so yeah, win-win, exactly. Yeah.
Are there any other questions? Awesome. Thanks again. Great
Cool.
talk.
Awesome.